Okay, welcome everybody to the December community meetup. You may be wondering why this isn't the uh, November community meetup. It's because we didn't have one in November. So at the end of the year, we tend to work around the holidays, and so you'll see a little bit of a shift with the meetups, but we will be back to our regular cadence starting at the end of January. Catherine, am I right that we are not doing one at the end of December?
Yes, January
Okay.
will be the next one.
Great. Wanted to make sure I properly informed you so that you can all show up and join. But thank you for joining us today. This is going to be another fun conversation with, we follow our regular format. So we'll do some housekeeping stuff and talk about the exciting things that are happening with Linkerd development and give you some news and updates. In fact, we have an agenda slide. So we'll talk about news and updates, the roadmap. We've got a really exciting demo with Moritz, who's going to show from Edgeless Systems, who's going to show us how he's integrated Linkerd and Marble Run together. And then Matei, who is always an entertaining and informational speaker, is going to talk to us about speeding up the control plane integration tests. So this isn't so much a feature of Linkerd as it is kind of behind the scenes, the person behind the curtain who is building, and you'll see some of the stuff that goes into making the build process for Linkerd better, faster, more efficient. We'll announce our December Linkerd hero, and then if there's time, get your questions ready so that we can play a round of Q&A/Stump the Maintainer. So we can get started. A couple of quick notes. We are always invited to join our Linkerd Community Anchor program. This is where you get the opportunity to tell your story of how you use Linkerd, how you've come to use Linkerd, the problems that Linkerd has solved for you. It's really exciting to hear about production stories or people who are using Linkerd in interesting ways. We will help you to craft your if it's a blog post or if you want to do a presentation, we'll help you do that. We've got Catherine here, who is fantastic at doing those things. And this is particularly relevant now as the KubeCon CFP is open, which I'll be talking about a little bit later. So there's a link there, linkerd.io/community/anchor to check out the details of the program and give us your ideas. We're always interested in learning more and helping you to tell people about what you're doing with Linkerd.
We're going to make you famous.
That's right. You will be famous worldwide. We've also got the CNCF Service Mesh micro survey. If you haven't taken it yet, I believe it's once a year. And when you take the survey, you can share who you are, how you're using Linkerd, where you're using it, other open source projects that you may be using, which is, again, it's always interesting to see how open source projects come together to help folks build their applications. I believe the window for this is closing. Do you know the last date, Catherine or William?
That sometimes later in December. They didn't know exactly when. So
it's a mystery date.
Yeah.
So,
but the sooner the better. So it's in.
Yeah, and answer sooner so that you don't miss the window. And then I thought there was a slide for another survey. I guess not. Good. We're not going to do that one. News and updates. So we've got quite a few things that are going on, and I have done a presenter fail. I've lost my notes. Give me 1 second.
Was that survey the same survey from a few weeks we emailed a few weeks ago, or is it a new one?
Great question, Oliver. No, this is yet another survey. CNCF.
Yet another survey.
Just making surveys left and right, and then if you don't get enough Linkerd respondents, then it looks really crappy. So we have to go around and beg everyone in the Linkerd community, please fill out these surveys, even though we don't create them and we don't control them. And it's just an endless hamster wheel from which we can never escape.
The survey hamster wheel. But, some folks like answering questions. And so if you like answering those questions, please do. But also, please do the survey.
Because it's super important for Linkerd. So make that little effort. Like, our team puts so much effort into creating this great technology. So take a few minutes to tell the world about it.
We're going to delete one line from the code base every hour until you fill out the survey.
That's right. Okay, I'm getting back to sharing here. Sorry about that. I wanted to be able to properly communicate to you all of the news and updates. So, got my notes ready. Okay, here we go. What has happened since October when we did our last community meetup? We did an MTLS workshop, again, with our great presenter, Matei. And in that workshop, he goes through the details of what MTLS is, how Linkerd implements it. We often get a lot of questions in Slack about some of the interactions and how for example, how identities are issued in Linkerd and some of the lesser known, I'd say, parts of MTLS. I think one of the things that I've learned as being part of the community is that MTLS isn't just the encryption between your services. It is the verification that the services have received their identities from a trusted source. And so I think that's an overlooked nuance. I believe there is a video for this, and we will put it into the chat so that you can check it out. Our next workshop is next week, December 14th, where I will be walking you through Linkerd in production. We have a link for that as well, which I have handy and can put into the chat channel here. Please join us for that if you are getting ready to use Linkerd in production or are already in production and are interested in learning techniques like debugging, managing your certificates, and important topics for running Linkerd in production. Along those lines, lots of news around workshops. We're going to continue to expand our workshops, and Catherine has come up with a great name for this, the Service Mesh Academy. You can sign up for your house that you prefer to be in. It will be like Gryffindor or Slytherin or something like that, but with much more clever names that are cloud native related. Just kidding. We haven't come up with those yet. But there are going to be lots of co-presentations where I know that Jason on our team has done some work with WeWorks recently, and I believe we will be doing stuff or have done stuff with Ambassador Labs. So stay tuned. Keep an eye out for more of those workshops that are coming. And just to add another note there, a lot of these workshops are going to be hands-on. So be prepared to come with your own cluster. And again, for example, the Linkerd in production workshop that we're doing next week, we're going to have Linkerd already set up. Our Kubernetes cluster running Linkerd will be set up. So when you join, be sure that you have all that ready to go. I will be creating a repository as well so that you can follow along, and because it's a time-bounded event, if you don't get to finish all of the exercises or all of the labs, as we're calling them, you'll be able to, on your own time, work offline and use the repository for that. So workshops. There's a lot going on there. As far as Linkerd development goes, we're still pushing towards the 2.12 release sometime next year. I think Oliver is going to talk a little bit more about that when we get to the roadmap part, the next section. But in the current Edge releases, there are a couple of exciting features. Endpoint slices are now enabled by default. There was a change, I think, around 1.17 where endpoint slices were introduced to eventually deprecate endpoints themselves. And so that is now enabled by default in the Edge releases and will be in stable 2.12 as well. the proxy init container can now be run as a non-root user, and that was an awesome contribution, if I remember correctly. And I think one of the other folks on the Linkerd team here can correct me if I'm wrong. That was a community contribution, so you can take away the root responsibility of the user that's running the proxy init container. So please be sure to try out all the Edge releases in your lower environments, or if you're feeling edgy, you can run them in production and let us know your feedback. We want to make sure that with each Edge release, we build towards a stable release that is going to have all the features and be stable. And finally, as I mentioned in the last section, the KubeCon CFP is open. So as part of, just in general, if you want to submit your CFPs for the service mesh track or for any track, observability is also a great one for Linkerd. Please reach out to us. We're happy to help with that as part of that Linkerd Community Anchor program. If you're like, no, I want to do this on my own and do it solo, please do that as well. But we're always interested in learning how folks are using Linkerd, and it's great for people in other open source communities to see how Linkerd is being used and to learn about it, because we don't have time to go and learn about every open source piece of software on the CNCF landscape map. So it's always nice to be able to get some distilled information from folks who are using it, like the Linkerd community themselves. So with that, let's move on to, we'll hand it over to Oliver for the Linkerd roadmap.
Hey folks, just a quick update this time. So I guess we last did this 2 months ago. We've got a clear idea of what's happening in 2.12 now. So we're going to march forward with basically an evolution of service profiles. So service profiles give you a way to configure a route-based configuration. And there's a bunch of problems we've kind of noticed over the years with service profiles and the way that they are discovered or mapped across clients and servers. And then they're not really aware of ports. And so now that we have servers, which are introduced in 2.11, we want to start hanging off new types of route policy onto those things. So that design's ongoing. There's another bunch of other kind of smaller changes going in. We're revamping the Helm charts. We're going to start semantically versioning those so that we can communicate breaking changes to the values YAMLs. We're going to split out CRDs and kind of the base level types into their own Helm chart, so those can be upgraded independently of the control plane. This will allow us to eventually have a bunch of default policies and default routes for the control plane itself as part of the control plane install. There's a number. We've also started to take a more aggressive stance around deprecating support for older Kubernetes versions. As we look forward, there's a lot of deprecations coming through over the next few Kubernetes versions, and it's hard for us to support looking things where things are deprecated, as well as Kubernetes 1.15, where like nothing is supported. So for instance, we've updated to start using lifetime and audience-bounded tokens, so that the service account tokens that are used by Linkerd for identity are only used for identity and not for other API access. That allows us to do things like run where there's no service account being auto-mounted, and kind of security forward improvements there. Endpoint slices was mentioned in general, so I think in 2.12 we'll probably drop support for everything before 1.19. So if you're not using if you're using an older Kubernetes cluster version, you should probably look at upgrading, because Kubernetes itself has dropped support for these things. So we're going to start matching the Kubernetes support matrix more directly. So if that's painful for you, get in touch. but it's going to be a lot easier for the project because we can't even do integration tests on older Kubernetes clusters in RCI. So need to start picking our environments there. Yeah, that's about it. I mean, follow the GitHub. We'll have more information on the upcoming work as that starts to get scheduled. But if you have any questions, don't hesitate to reach out.
Great. Thanks, Oliver. All right. So as you know, we have an external speaker every time that we do one of these community meetings. And so this month we've got Moritz from Marble Run, who's going to show us what Marble Run is, how he has integrated it with Linkerd, and give us some more detail about it. So let's get the conversation going with Moritz.
Hey.
How are you?
Very well.
Good. Thank you for joining us.
Yeah, I'm glad to be here.
Yeah, so I want to take a minute to introduce you to the Linkerd community. You're the chief architect at Edgeless Systems and the security software engineer there before that. How did you come to work at Edgeless Systems, and what do you find most interesting about security?
Yeah. So before that, I was doing research mostly on software security, and was very technical, very deep down. And then for several reasons, but also the opportunity I saw at Edgeless, I decided to quit research and go the route of software development, creating stuff. That felt great. But I'm still very, very passionate about computer security, understanding how things work deep down in the tech stack. And somehow Edgeless and me, we found each other, and now we had a great start.
It was a match made in cloud security heaven. I'm glad you mentioned your research, because I noticed on your profile, your LinkedIn profile, that you have spent time in two of my favorite places in the world. One is Nice, France, in the south of France, and one is in Santa Barbara. Were you able to get any research done being in such two such beautiful places?
Yeah, I totally agree. Wonderful places. Yeah, I was very fortunate to have great people there around me that joined the passion for the research. So together that was great. But yeah, I'm a passionate cyclist. I guess both regions are also great for that.
Yeah, really good for cycling.
Definitely did a lot of cycling there.
Very cool. Well, good. And so before we jump into the demo, I'm curious to know, give us a little overview of Marble Run, how and why it was created, and the main reasons that it exists.
Yeah, I think I heard a talk or read a blog post from William on why Linkerd was created, and I think there are a lot of similarities. We have this.
So Linkerd inspired Marble Run is what I'm hearing.
to some extent, you could say, yeah, definitely. So we had this confidential computing on one end, this very technical thing, new technology, and then we wanted to create software for it and follow the cloud principles, use the cloud native stack, and there was this gap we tried to bridge, and part of it was let's say the service mesh layer, and there were some additional challenges we had to solve that only apply if you or mostly apply if you use confidential computing workloads, and for those we built Marble Run and basically added to what the service mesh layer is already addressed by Linkerd, and I think that's a very cool part of this whole tech stack, and they look very cool together.
Well, that sounds great to me. I can't wait to see how cool it is. So I'm going to stop sharing my screen here, and we'll hand it over to you so you can show us all the coolness.
Yeah, thanks. Does that work? Do you see the screen?
I see it.
That's great. Okay, let me just have a few quick slides to just briefly introduce the concept of confidential computing. I'm not sure if you all know what that is, and then we can go from there. So, as I said, we have this confidential computing technology, and we already have our cloud native stack where we use to deploy on the cloud, and part of this is the service mesh layer, and of course Linkerd. And now we create malware to augment the service mesh layer for creating confidential deployments. The idea of a confidential deployment is that you have additional benefits of runtime encryption of your data, so nobody can steal your data from memory or peek inside. You can have cryptographic verifiability of how your topology of your deployment looks like and what's running there. And then you want to protect against very powerful attackers that might come from the inside. Let's say you need to protect against your Kubernetes administrators or cloud administrators, not because they are malicious, but because legislation says they can't have access to whatever's running there. And also, of course, hackers, rootkits, everything that could run on your machines on the cloud infrastructure. And this is very useful for, we typically differentiate two use cases. One is you want to have an additional protection of your existing workloads, let's say for keeping the cloud provider out to be compliant to certain standards. But you can also imagine new use cases that you can build with confidential computing that you couldn't do before. Think about multi-party computation or privacy preserving, data pooling, data processing, this kind of stuff. And how do we do this? The term we use is confidential computing, but below that, what it refers to is a hardware technology that is all about what's typically called enclaves. So you create secure, isolated environments that are always encrypted and can be peeked inside from no other component in your tech stack. That means not your hardware, or the hardware components, not your hypervisor operating system, other workloads running on the cloud can't peek inside those enclaves. And the third part is they are verifiable. So you can prove from the inside of the enclave as well as from the outside that this is a secure enclave and this has all the properties you expect it to. It runs all the code, has all the data that it needs. So this is the tech that sits below it. And it's, I would say, something that's very much growing. Most of the big hyperscalers provide some form of confidential computing. Of course, they all have their different terms, but they all have the latest hardware from Intel and AMD that have their particular implementation of confidential computing, and then AWS has their own system based on their Nitro infrastructure. So this is the tech stack below. So let's you already mentioned the introduction, where we came from with Mabaran. We initially built some software to create secure enclaves for Go code. So you could create confidential containers based on your Go workloads. There exist other toolings for other languages. So you can create confidential containers or confidential applications. But now, as I said, we have this problem similar to the service mesh philosophy, that we need to mesh them together, and then we have all those tricky tasks that we have to solve in between those services. First one, of course, how can two confidential containers talk to each other and have a form of identity that they can trust and they can verify before they establish secure connections? And similarly, how can me as an outsider, if I want to access an application, let's say through a web interface, how can I be certain that this is a secure confidential computing deployment, and everything is end-to-end encrypted in there. You mentioned MTLS, I think in the news and updates or roadmap, I'm not sure. For MTLS, we have the problem that if you use the MTLS of Linkerd, it terminates inside your sidecar and then goes through the host into the actual container. If we don't trust the host, because the host is not part of the secure enclave, we have to terminate those connections inside the enclaves. So they are end-to-end secure between those environments. And then if we have some secrets and we want to make sure those secrets are only with me or with my secure enclave and my deployment, and they are not passed through some untrusted host, untrusted infrastructure component, I can't use the regular Kubernetes secret management, for example. So I need a way to securely provision enclaves with secrets. And finally, of course, I want this all to be updatable I have my usual deployment mechanisms, and I want to use them as before and don't want to adjust that much. Okay, this was a very fast, hopefully not too fast introduction in going from what is confidential computing to what we try to address with Marburun. Let me give you a more hands-on example. But before I show this,
yeah. So what I can say as you're jumping into that is I took a peek at the Marburun docs, and everything that you've covered here seems to be pretty well documented there. So if anybody in the community is looking for more info about this, definitely check out the Marburun docs.
Yeah, thanks, Gunnar. That's a great tip. Yeah, we forked your Emojivoto demo application after you added the license. Thanks for that. And what we try to show here is that we take your application, we don't modify the code at all. The only thing we modify is the build process. So what pops out are not Go binaries, but are secure enclaves running those Go binaries. That's the major change. And from that point on, Marburun is taking care of those confidential computing parts, and Linkerd is your usual service mesh doing what it did before, with one exemption as we can't use the MTLS of Linkerd for encrypting the traffic. You could do, of course, add MTLS of Linkerd on top if you use that for identity purposes. But you don't need to, because in confidential computing, the identity is managed through those verifiability attestation features of the underlying hardware. So let me maybe quickly give you an understanding of what happens behind the curtain, and then I can run it in on the actual cluster. So we will install Linkerd as usual. We will install Marburun. Follows similar patterns. We were inspired a lot about this. We were great fans of how easy and approachable Linkerd is from an user perspective, and we try to we took great inspiration from that from Marburun as well. So you install it very similar. You set a manifest that basically describes how your deployment looks like, what services should be able to run there, how they should, what's their identity basically. And then you install the Emojivoto, and when those containers start up, they connect to the Marburun control plane, authenticate themselves using this verifiability feature of confidential computing, which gives them basically a proof of identity. And then Marburun provides them with credentials for mutual TLS and provides them with potential secrets and all this kind of stuff. And then I, as a user, can connect and can verify the identity of my application from the outside, again, using Marburun to get a root certificate that is then used to establish secure connections to your application. So is the font big enough?
It's a little small.
Let me increase it a bit.
There you go. That's good.
So I already installed Linkerd. Because I'm sure you folks know this procedure. So, 1 sec. Let me see. Let me install Marlboro and I create a namespace, and then I set it to be for being injected by Linkerd automatically, and then I can install it. It takes just a few seconds. To be ready.
So I didn't realize that you're actually injecting the Marble Run pods with Linkerd as well. So that is providing the MTLS between Marble Run control plane components as well as the containers?
It's in this case, it's not about the MTLS. It's
Okay.
more about that. Also, I can basically in Linkerd observe the communication between my application and the Marble Run control plane, and have the benefit of that.
Yep. Yeah. So it's.
Yep. Okay. And
Sorry, Charles is speaking on mute.
I was wondering because it was stopped so abruptly.
Yeah, I was just making the comment that it's interesting to see the use of observability when we're talking about the security context here, being that these are all kind of the core concepts around Linkerd and Marble Run. But yeah, that makes sense to me.
Mm-hmm. And then I'll just need to expose the Marble Run control plane to me as the engineer here, basically. So let me do a port forward of the coordinator client API, and then export this. So I can use it, and then I can set the manifest. For the sake of this demo, you can check in the docs. Basically, the manifest is a description of the confidential components of my deployment. So Marlboro is able to verify their identity, provide them with the necessary secrets, all this kind of stuff. It's basically an addition to your let's say to your regular deployment descriptions in your YAML files. Okay, so this is a lot of output, but essentially I set the manifest that's stored in a JSON file here, and it told me the signature and that was set correctly. And then from this point on, I can use the usual workflow for deploying Emojiboto and interacting with Emojiboto, and Marlboro is taking care of that. All those components, your web front end, your voting service, your emoji service, that they are communicating through secure channels, that they are authenticated to run in secure enclaves, and nobody can leak your votes. So let me annotate those namespaces again. So I have to add the namespace for the Linkerd injection as well as the Marlboro injection. Where Linkerd will inject a sidecar, Marlboro basically can't use the sidecar pattern because we need to run everything inside the secure enclave. So when we create the Emojiboto app as a confidential container, we already inject our data plane in there. This is maybe a key difference in the architecture. And then I can install the Emojiboto app. I'm using a Helm chart. I think in the original Linkerd demo, it's using the YAML files directly, but it's basically the same deployment. And then I can expose the web front end. And I can also start the Linkerd dashboard maybe, and then we can have it. So the application is running on localhost 8080. Hopefully, let me open the Linkerd dashboard first. All right, so we have the emoji voter namespace. We have the Marlboro namespace. Let me quickly check if something. Yes. And I get a security warning because what's happening here is that we also support the, it's probably mutual TLS is the wrong naming here, but let's say we call it the transparent TLS, that we can add TLS to connections also facing the outside world and use a certificate that's bound to a verification in the world of confidential computing. It's called a remote attestation statement that proves that this certificate belongs to a container running inside a secure enclave, and exactly what container this is. So I could check this certificate. Oops, that was not what I wanted. Check the certificate here, and it will tell me that this is a certificate signed by the Marlboro coordinator. And Marlboro has features or has tooling to automatically verify this certificate on the client side, and I could export it here using Marlboro and then import it in my browser. And if I would use the browser, I could then verify that this is a valid certificate from a secure enclave. But I skip it for the sake of the demo, and then we access the emoji vote demo as usual. Have the same kind of functionality. Could use Linkerd as usual. What changes for Linkerd is that it's now only seeing encrypted TLS traffic between the emoji voter services, because they are encrypted directly inside the confidential container and not through the Linkerd sidecar. This is necessary, as I said, because people could steal information in this link between sidecar and the actual container. Yeah, but from that point on, I could scale up and down. Everything would work as usual, and applications would be automatically verified by the Marlboro control plane. Okay.
Yeah, that's very cool.
This was maybe a little bit fast, but I hope I still got a nice impression of, or a nice introduction into confidential computing. Maybe if you get interested, as Charles said, check out the documentation. There's a lot more detail in there.
Definitely some new concepts that were introduced there to me. So is the enclave, is that a different kind of container, or is that within the container there's secure code running that's managing the traffic?
Mm-hmm. It depends on what flavor is used as the underlying technology. One is called SGX from Intel. Then it's basically a secured process, an isolated process that's running inside the container. If maybe you're familiar with the Kata containers, they are building a concept based on AMD's solution for confidential VMs. Then more or less the whole container is in an isolated state.
Gotcha. Well, that was really cool. I have more questions, but we are a bit short on time, so we're going to move on. I really appreciate you sharing that with us. Again, it's really, I enjoy seeing open source software being put together, especially in secure environments like this, for folks who are in in the Linkerd community who are in banking or in telecoms or anything that requires like regulatory security or confidential computing. I think this is going to be really useful. So really appreciate you sharing that with us, Moritz.
Thanks, Charles. Thanks for having me.
Okay, now let's quickly jump over to hear what Matei has to tell us about speeding up the control plane integration tests.
Yeah, can you actually share the screen, Charles? I'm not I'm not ready to share mine. Do you mind driving the slides for me?
You betcha.
And just, to set the expectations straight, I think Moritz set the bar quite high with the slides. Like, I'm not going to have the same beautiful slides here. It's all like a collection of screenshots, but, did my best.
There were some cool animations in there.
Yeah. Anyway, yeah, I'm going to talk about the integration tests and kind of the CI pipeline. Now, before we actually go to the next slide, we don't generally talk a lot about all of the CI improvements that we make. We don't document those in the release notes, but they're there. And if we go to the next slide now, Charles, this is something that we're kind of doing continuously. And that was a bit of a bad pun on my side. Improving continuous integration is a continuous process, but it kind of is. So this is all from, I guess, the last month, around October. These are all PRs that made it in and that are all kind of aimed at making the experience better on the CI side. And if we go to the next slide, I think one back. Did I mess this up? Yeah, there we go. So why do we make improvements to the CI? I know this is kind of a rhetorical question because I just said it's a continuous process, but we have a lot of tests. And as a contributor and as a maintainer, it can be a bit of a headache. Like on the right there, I have a bunch of failed runs from some of the PRs that I had, and some of them took like 2 hours. Like that's a long time just to have some basic checks run. On the bottom there, those are all of the emails that I get. So if I don't answer to emails, it's probably because I'm spammed with all of these, failed actions. And finally, at the top, is there a concrete problem? Yes, there is. We have deep test slowness. So obviously, we're concerned with this, first because we want to make sure Linkerd has a very rigorous testing process. We don't want to push something on main that's going to end up blowing your stuff in production. And second, we also want this to be a good experience for both contributors and maintainers. If you're going to contribute code or help out with a release, well, we kind of want it to be a seamless process. And I had my fair share of nights where I had to stay and babysit the CI until it completed for a release. So it's kind of annoying. So on to the next slide. Let's see what we can do to fix this. Actually, I was jumping too far ahead. So taking a step back, no, go, go back. Yeah, so just to give everyone an overview of what we're doing with our testing. So naturally, if you're going to be interacting with the code a lot, chances are you've seen this before. I know, Alexander, maybe you had your run-ins with the CI because you've pushed quite a bit of code. But basically, when we have our integration tests, we split it all up into different test suites. And those test suites are responsible for testing a specific interaction or a specific use case. So on the left, we have our integration test matrix that we do in GitHub Actions. And all of these names there that you see, those are all of the test suites that we run. And each test suite has a number of tests that we use to kind of assert correct behavior. So if we look at it, we have a deep test suite, and this kind of encompasses Linkerd's basic functionality. Can we have connectivity? Can we test MTLS? Can we test that all of our endpoints are up and running, service discovery, and so on? And then there are a bunch of different tests depending on what our use case is. So if we're using external resources such as RabbitMQ or other databases, we have some tests for that. If you bring your own Prometheus, we have some tests for that. So most of our functionality is split across these different test suites that we try to run in parallel to reduce the time. And on the right, you see all of the tests that we're running for the deep suite. So our deep suite, I think, is the most comprehensive that we have out of all of them. There's a bunch of stuff that we test in there. opaque ports, stat, we're testing egress, we're testing routes, service accounts, and so on. So if we go to the next slide. So there's an obvious problem here with the slow tests, and maybe you caught it a bit in the last slide because we had all of these numbers that popped up, and those were all like the run times and the execution times of our tests. But it turns out that actually solving this problem of having slow deep tests and slow tests in general is quite hard because most of it needs to be an empirical approach. You can't really just come up with some theory like, hey, I think we can increase some numbers if we do this and that. You kind of have to observe it, right? You have to get some benchmarks, and you have to do experiments, and you have to see what works and see what doesn't. But this is kind of at the expense of our code base, right? Because you don't want to remove tests out of a sudden and add new tests, and that'll just make a mess out of it. And like I said before, we need to have a rigorous testing process. There are two steps, though, that we can kind of take here and that we came up with. So this is kind of an incremental approach that we're taking to improving the CI. And what we wanted to focus first and foremost is to isolate these tests further. We have our test suites now, but some of them are, like we'll see a bit further, sorry. They're a bit unnecessary. They're a bit redundant. So we want to isolate tests even better and kind of reorganize them. And that's because we want to leverage as much as we can parallelization and GitHub Actions. That's our CI of choice. And basically isolating and parallelizing tests better comes from removing dependencies that have huge overheads and removing duplication. And finally, we want to optimize each individual test as much as possible so that we don't do silly things in there. All right, can we go to the next slide? So going back to our first picture, and that's why I included a slide there, can you spot the duplicates? So right now we have 3 deep test suites that essentially run the same test, but they run it differently, right? So we have the deep suite that runs as usual. We install Linkerd through the CLI, we run the test, but then we also do the same thing for Helm. We install Helm, and then we run the same test suite just to test out that it works installed with Helm. And it's kind of redundant if you think about it, because we already have installation tests in place. We test that we can install everything properly. We test that we can upgrade everything properly. And don't take my word for it. You can look through the actions and through the tests, but we do that already. So this is kind of a rhetorical question again. Can you spot the duplicates? Well, I just kind of drew the lines. Yes, you can. And they're very obvious, and they cost a lot of time. So each time you run an action and something fails, you have to run the whole integration test suite again. And that pretty much takes up a lot of time. And for the deep tests from the deep suite, in total, there are a couple of tests, and I think it takes 22 minutes approximately in execution time. A huge chunk of this, again, comes from some smoke tests that we do with the install, and these run as part of every single test suite. So what I'm basically trying to say is that we have a lot of duplicate tests that test the same thing, and there's a lot of redundancy in there. And in general, redundancy is good, but not when we want to improve CI speeds. Can we go to the next slide? So the first step is to isolate tests. So this is still all ongoing work, but we have 2 simple steps here to kind of leverage GitHub Actions better and get like better parallelization out of this. So first, we want to remove duplicated test suites. So Helm Deep, for example, is going to go out. Sorry for all of the Lord of the Ring fans, because this is kind of a reference, so I'll be sad to see that go. But then we also want to move tests to appropriate suites. So as part of the deep test suite, for example, we have a huge dependency on our VisStack. And that's not necessarily a bad thing, but we have a bunch of tests that could be easily split out, put into a different test suite, and run in parallel with the Viz extension. We don't need to have the Viz extension for every single control plane test that we run, because chances are it's not mandatory. So for those tests, what we want to do is remove the dependency and see how we can run the same tests, assert the same behavior when it comes to connectivity, but without kind of relying and leaning so much on our own visualization stack. Can we go to the next slide? So besides that, there are still more optimizations that we can do in the code itself. And these are 2 screenshots that I have from some PRs that have been merged or in progress. And first, like I said, we want to remove this Viz dependency that we have on tests. And second, we want to optimize code execution as much as possible. So in a bunch of tests, we were blocking with time.sleep. Testing in Kubernetes is kind of hard. It's a fickle environment. You always have to spin up pods to kind of test that everything works end to end. And a lot of flakiness comes into it because of it, right? So for example, a lot of times that our CI fails, it's not because we introduced a breaking change or the contributor introduced a breaking change, it's because the pods didn't come up in time. And the easiest solution to this is to just add a bunch of kind of block statements in there, block the execution of the code, wait for the pods to come up, and then resume your test. But naturally, this takes a lot of seconds. And again, this is all very hard to estimate because what happens on my local machine is not necessarily what will happen in GitHub Actions. So we're very optimistic whenever we block the execution of a test because we want to leave enough time for the pods to come up. So for example, in this case, the simplest solution was to just swap that out with retries. And that allows us to make sure that we have a maximum ceiling of time that we're waiting for a test to run, but it can complete much sooner. So that's much better, for example, than halting the whole execution of the test just to be sure that the pods come up. Next slide. Yeah, I guess that's it. Sorry, this is a very quick and impromptu presentation, but my main takeaway from this that I'd kind of like people to take is that we're constantly trying to improve our CI. And the two main ways that we're trying to do that right now is by leveraging parallelization as much as possible and optimizing what we can in the tests. There's definitely room for improvement and there's room for involvement. So if anyone wants to learn a bit more or wants to do tests, I mean, I'm not sure why you would. It's not the most fun thing. I find it fun, but not everybody finds it fun. And if you want to get involved, ping me or reply directly in the issue, or you can ping anyone from the team. This is a team effort, and we've all been super involved in it so far. And yeah, we hope to keep the trend going so you can all have a nice contributor experience. Any questions? I breezed through it, but yeah, there's an issue up. I'm gonna post a link to it in the chat. So I think I did a better job at summarizing everything in the issue itself. So if you want to have a look or are curious about anything, let us know.
Awesome. Thank you, Matei. That you made a good point at the beginning. Well, the whole thing was a series of good points. But the point at the beginning is that we don't often, when we do release notes, we focus on features and bug fixes and things like that. And I've seen some of the frustrations of the Linkerd team as the CI builds failed. So the work that you're doing, while not glamorous, is certainly helping people. It's going to maybe save people from having a meltdown or having their heads blown or something like that. So it's totally valuable and we really appreciate it. So thanks for sharing that with us. And I think it's important to bring these things to light. So we appreciate it. Okay. Yeah, well, thank you. Okay, so got just a few more minutes here. The next thing up for us is to announce our Linkerd hero. So without further ado, the Linkerd hero for November, December, you get 2 months. This is a special hero, is Alexander Tarasov, who is with us today. Thank you, Alexander. Yeah,
it's me.
a few words, please.
About what? About myself?
About yourself. You know, what's on your mind?
So I'm the director of engineering in UK startup, fintech startup Panna Money. We do personal assistance for small and medium business, and for us, I think that security is really matter, and Linkerd helps us with this to make zero trust environment inside of Kubernetes cluster. So I think that's its main benefit that we got. So it's surprisingly, so it's not about reliability or observability because we are not too big. So we're not large company. We don't have some kind of high load, I think. So, so we have clients and we care about them and care about their money.
Well, we care about you. Thank you for being our hero. And the reason that you're nominated and made the hero is because you not only have been using Linkerd, but you took the time to write up, I think, 3 articles to share with the community. So, you know, the community support is there. We can tell that not only do you care about your clients, but you care about the community. And so We really appreciate it. Congratulations. Thank you so much. The accolades are all yours today. And with with that, we have, oh yeah, don't forget to nominate the hero for January. We tend to announce this in Linkerd Slack just as a reminder the week before the community meeting. So we'll be doing that in late January. But if you've got somebody in mind, go to linkerd.io/nominate-hero and fill out the form today. And we don't have much time for Q&A. I don't see any questions in the chat, so we'll skip the questions. Well, no, we'll give you an opportunity to ask questions. Anybody got a question? Going once, going twice. Done. Okay, well, thank you again to Moritz and Matej, who are both Europe-based, and it's evening time there, so it's well after the clock. You both earned yourselves a pint or a glass of wine, whatever it is you're doing to celebrate the evening. Thank you so much for sharing the things that you're working on. And again, Alexander, thank you for your awesome articles. We'll be sharing those with the community as a whole. And thank you all for attending. This has been another fun Linkerd community meeting. And one other note here, we're talking about Matej doing stuff behind the scenes. We also need to give some gratitude to the folks who make this whole meeting possible. Catherine's here. She's always helping, as well as some other folks that are behind the scenes. So thanks again. And I hope everybody has happy holidays and a great start to your weekend.
Thank you.
Thanks,
See you all
Charles.
next year.
Thanks, Charles.
Bye-bye.
Thanks for running this. Bye-bye.
Thanks. Bye-bye.
Bye.